All right, let's dive right in. We're about to explore a theory of everything that might just completely flip how you see, well, everything. The idea is pretty wild that our entire reality is a single, self contained system that literally defines its own existence. So, let's start with a big question. What if the whole universe, from the tiniest particle to the biggest galaxy, is all running on one single elegant principle? I mean, what if there's one equation that could define not just bits and pieces of reality, but the actual fabric of existence?
And here it is. This is the equation we're going to unpack today. Yeah, I know it looks almost too simple, right? But trust me, each one of those letters holds a key to understanding a pretty profound puzzle: how our universe actually works.
Now here's the kicker, the really core idea. This equation is completely self-referential. Each part defines the others in this perfect logical loop. See, time is defined by energy, and energy is defined by changes in information, and so on and so on. It's a system that needs absolutely nothing from the outside to make sense. It just is.
Okay, so to really get a handle on the whole system, we need to learn its language. So let's break down each of these four building blocks, one by one. First up, we've got information, or I. Now, don't think of this like data on your computer. This is way more fundamental. It's the actual organization and geometric structure of things. You know, the precise way atoms are arranged in a crystal, or the pattern of planets zipping around a star. It's basically the what of reality. Next is coherence, or C. This is all about synergy. It's a measure of how well the different parts of a system work together, how in sync they are. A perfect example? A laser. It has crazy high coherence because all its light waves are marching in perfect step. Now compare that to a regular light bulb, which is the total opposite, very low coherence. Its light is just chaotic and scattered all over the place. Then there's energy, E. And this is a really crucial distinction you've got to get. In this way of looking at things, energy isn't a thing. It's not a substance. It's the process of change itself. It's the engine that's constantly driving the transformation from one arrangement of information to another. And all of that brings us, finally, to time, T. So this theory suggests that time isn't some universal clock just ticking away in the background for everybody. Nope. Instead, it's something that emerges from the other parts. The duration a system experiences is literally determined by the balance between its organized, coherent structure, that's the I times C, and its rate of change, its E. Okay, I know, that's a lot of theory, but how does this abstract idea actually show up in the world we can see and touch? Well, let's take a look. Check this out. This table illustrates the idea perfectly using leaves. Think about a pine needle. It's got a very simple shape, right? That's low I. But it's highly coherent with its cold environment. It's great at surviving the cold, which means it has a low energy exchange. The result? A long T, a long lifespan. It's an evergreen. Now, an oak leaf is the total opposite. Its complex shape gives it high I, so it can soak up tons of sunlight for photosynthesis, which means a high energy exchange. The result? A short T. It's deciduous. Each leaf is just a perfect, elegant solution to the equation, totally optimized for its environment. And this principle is absolutely everywhere. Even something as fundamental as light bending when it hits water, refraction, can be seen as the universe just finding the most efficient path possible to keep that balance between information, coherence, and energy. So, we've seen this equation in the familiar world of leaves and light. Now, let's scale this thing way, way up to the cosmic boundaries of reality itself. We're going to places where time seems to just stop. And this is where the equation reveals this incredibly beautiful symmetry. It actually predicts that time stops at two completely opposite extremes. On one side, you've got a black hole. Here, information and coherence are squished down to an infinite maximum. Everything becomes one through pure compression. Then, on the other side, you have a photon of light. It has the most minimal structure, minimal integration. Everything becomes one through utter simplicity. You see that? Two totally different paths, maximum complexity and maximum simplicity, and they both lead to the exact same destination, a timeless existence. Wow! And that brings us to the final, and maybe the most mind-bending part of this whole framework: how reality might actually be computed moment to moment, right down at the quantum level. So to understand this, we need one last concept, omega, the coherence coupler. The easiest way to think of it is as a kind of universal matchmaker. It's a value between 0 and 1 that decides whether any two systems can connect and how strong that connection will be. A value of 1 is a perfect match. 0 means, sorry, no interaction possible.
This is where it all clicks together. This theory proposes that quantum superposition, that bizarre ability of a particle to be in multiple states at once, isn't just some weird, unexplainable quirk. It is the very engine the universe uses to run a constant, universe-wide calculation.
So how does this calculation actually work? Okay, step 1. All the potential futures for any given system exist all at the same time in superposition. Then, step 2. The universe calculates omega, that coherence connection between every single one of those possibilities. And finally, step 3. The possibility with the strongest connection, the one with the highest omega value, is the one that wins. It collapses out of superposition and becomes the single, solid reality that we actually experience. And that leads to this incredibly powerful idea. The normal, classical world we see around us, the world of solid objects and definite outcomes, that's the final answer that pops out of this continuous calculation. But the weird, fuzzy world of quantum mechanics, that's our little glimpse behind the curtain. It's a peek at the calculation itself, where all the possibilities are still being weighed.
Which leaves us all with one final, pretty provocative question to chew on. If this framework holds up, it means our reality is the result of a continuous, self-organizing quantum computation. So, the question is, are we just living inside the answer to a cosmic calculation? And if we are, what was the question? Thanks for joining me.